Do you know if all of the calculations in your code do exactly what you expect them to? Or if that behavior changes? Probably not. So this week we're going to help you put your mind at ease and solve one of the most common issues with scientific code, which is lack of testing. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I want to show you how to alleviate your fear of, did my code's behavior change? And that's by using testing. Testing is a huge topic, and we're certainly not going to be able to go into a full depth on it and cover all the tools, but I want to give you some basics because any testing is better than none. It future-proofs you against other libraries changing how they do a calculation that then influences your results. It also is a good way to prove to yourself that you really understand what the code is doing. Some people say that untested software is indeed broken software, and I very much agree with that. So for this week, we're going to create a very simple function in myfuncs.py. So you see I have a file here. This could represent a library of functions that you've made for your own use, or it could be your script. And then we have another file, test.myfuncs.py. We're going to use a framework called PyTest that looks for anything that says test in the file name at the beginning or at the end of the file name and is a .py file. So we're going to start out in myfuncs.py and write our code. So I'm going to create a function. It is a Fahrenheit to Celsius converter. It takes a temperature. Notice I didn't use temp. Temp is a pretty bad variable name, really. It often stands for temporary. In meteorology, it often stands for temperature, and it tells you nothing about what it actually contains. It's just one of those be nice to yourself things. Indeed, we're going to add a docstring as well because we're going to be nice to ourselves. Okay. So let's go ahead and write our calculation. So I'm going to return temperature minus 32 times 9 divided by 5 and save. So you might go ahead and use this in your code and say, well, I surely can write a simple temperature converter. But as you'll see, that might not be the case. There are lots of little gotchas, even in something this simple. So imagine how many there are in your more complex scientific code or processing routines. So let's go over to test.myfuncs.py. First, we need to actually import the thing that we just wrote. So from myfuncs, import, and then our name was Fahrenheit to Celsius. Now we're going to write a function. So each of your tests can be a function. There are some more complex ways to do it as well. But this is how many of the tests are in MetPy. And if you wonder, how do I test something? What I often do is go find a library that does that thing and see how they did it. So how do I test images? Well, I went and looked at Matplotlib. How do I test NumPy things? Go look at NumPy or go look at Pandas. Many of them have test helpers that make it very easy for you to do the test. We're going to follow something called the four-phase test pattern, which is setup, then we exercise the code, then we verify our results, and then we do any cleanup. And remember I said that this is all going to be in a function, and your function name needs to begin with test as well. So often I see people forget to do that, and then, well, the test suite passes because none of the tests ran. So you want to make sure that if you add a new test, that more tests than ran last time actually run. And we'll see how that works. So here we're going to test Fahrenheit to Celsius, freezing. So nice description name, or descriptive name. You're never going to have to type this. The test framework is going to run it for you, other than when you create the function. So be as descriptive as you can. Test temperature conversion with freezing point of water. And I'm going to go ahead and indent. Okay, so setup. What do we need for the setup? So temperature input is going to be one thing. And in this case, for freezing in Fahrenheit, that's 32 degrees. And then our truth is what I often call it. What's the output that we know we want? Well, we know it's going to be 0 degrees Celsius. Now we need to exercise. So I'm going to call it result equals Fahrenheit to Celsius, and we pass it our temperature input. Now we verify. In the verification, we're going to do something called an assert. That's just going to throw an error if this equality that we put after it is not true. So I'm going to assert that the result is equal to the truth. Now, there are some nuances here. If you're doing floating point number comparison, you need to be a little more careful in this. Those are all topics for future MetPy Mondays or for you to dig into as you get more into testing. This is just to get your feet wet. And finally is the cleanup step. Luckily in Python, we don't often have the cleanup step. In many languages, this would be something like destroying an instance of a class or unallocating memory. And occasionally in Python, we will have a cleanup step, but in this case, we don't. But we still want to think about that 4-phase test pattern: set up, exercise, verify, and then clean up. So I'm going to save that, and I'm going to open a terminal or Anaconda prompt if you're on Windows. And I'm in the folder for today's MetPy Monday, MetPy Monday 1223. I'm going to run the command pytest. And pytest uses what we call the Hollywood philosophy, which is don't call us, we'll call you. And they have very little output if the test succeeds successfully. You just get a little green dot. And if a test fails, then you get a verbose output. So we have one test and it's failing. And it tells us the name of the test that's failing. And it shows we're saying minus 25.6 is equal to 0. Well, that's not true. And we know that freezing is not minus 25.6. So let's go back to our code and look and see what the problem could be. It's right here. Add some spaces around that to make it a little easier to read. We're multiplying 32 by 9, dividing by 5, and then subtracting that from temperature. We need to have parentheses here. Temperature minus 32. So let's save that. And now let's go run our test again. Okay, so now we have one test that's passed. Remember, one test. So let's write another test. What I would encourage you to do here is pause the video and write your own test. I'm going to use the boiling point of water. That's another critical point in the water phase diagram. But you can use whatever point you would like, maybe minus 40, because we know that both of those should be the same in Fahrenheit and Celsius. But go ahead, pause the video, try writing a test, and make sure that it runs. All right. So I'm going to go ahead and actually, instead of copy paste, I have got into trouble doing that before by forgetting to change something. So let's write the test from scratch. So Fahrenheit to Celsius, boiling, test temperature conversion with boiling point of water. Our setup, the temperature input, and the boiling point of water in Fahrenheit is 212 degrees. All right, so that is our temperature input. Our truth is going to be 100 degrees Celsius. Then we exercise. So the result is equal Fahrenheit to Celsius, temperature input, verify, assert, result is equal to the truth, and clean up, but we don't have any. Okay, so let's go run our test suite. Make sure you save the file. And you say, great, everything's good. But it's not, because notice that I just have one test passed again. This function does not begin with test. So we wrote it, but it's not actually running. And this has definitely caused issues in packages that you've used. A programmer accidentally forgets to put test here. So let's add that. And now let's run the test suite. 1 passed, 1 failed. Okay, so we have assert 324 equals 100. That's not true. Well, we know that boiling point of water is not 324 degrees Celsius. So something's wrong. So let's go back and look at our function. And the astute among you probably have been screaming at the video since the beginning that this is indeed backwards. This is something that I do when I do this conversion all the time, is forget which way it goes. But it should be 5 divided by 9. But notice our first test didn't catch that because it was 32 minus 32, and 0 times anything is 0. So this is why you have to have multiple test cases to try to capture as many edge cases as you can think of. Will you capture everything? Probably not, but it's certainly better than having none. All right, so now let's go run it on the command line. Now when I run PyTest, we see I have 2 tests and they both passed. So I hope that this encourages you to go out and start writing some tests for your code. It certainly makes me sleep better at night knowing that my code has been checked and verified and I know if something has changed. Testing is a very deep subject, as I said, and if you would like to see some more on testing, let us know. We can always provide more testing resources. Thank you for joining me, and I'll see you on next week's MetPy Monday.